Lesson 9 is mainly about multiplication and division of signed numbers. Now we've been working with addition and subtraction of signed numbers, and we've also been talking about the concept of opposites. So some of those things will help us understand multiplication and division of signed numbers. For example, let's just start out with something simple. 2 times 2. Okay, now we don't have any signs in front of those, so it's understood then that that means positive 2 times positive 2. And you know that that means that you're adding 2 twice. That's what 2 times 2 means. And so what we could do is, on our number line, just start at 0, add 2, and then 2 again, and we would get to 4. And hopefully you do know that 2 times 2 is 4. But let's try another one. 2 times negative 2. I'll write this over here. 2 times a negative 2. And we usually like to put that inside parentheses when there's a negative sign, just so there's no confusion with subtraction or anything like that. We're saying that that is a negative number. So here we're adding negative 2 twice. That's what that means. 2 times negative 2. And so now what we'll do is we'll add negative 2 and then another negative 2. And so we get negative 4. Now we have one more combination here. That would be negative 2 times negative 2. Let me just put a negative sign in front of that 2 there on the left. So think about that. What we've done, we're saying now the opposite of 2 times negative 2, right? Because that's what a negative sign also means, is the opposite of. So if 2 times negative 2 is negative 4, the opposite of that would be a positive 4. So we'd be back over at positive 4. So when you're working with multiplication and division of signed numbers, there's a couple of rules that I've written there that will be helpful to remember. Whenever you multiply like signs together, whether it's positive times positive or negative times negative, the result is a positive number. So like signs yield a positive number result. Unlike signs, those yield a negative number, like our 2 times negative 2 example. We showed that that equals negative 4, so we had a positive times a negative. So unlike signs, those yield a negative number. And that works in multiplication as well as division. Now, division of signed numbers, that's a little bit more complicated to describe compared to multiplication, where we can just use a number line like that. Compare it to addition and subtraction. Compare multiplication and division to addition and subtraction. For example, addition and subtraction, if I had 3 plus 2, that equals 5, I could just undo that addition that I just did by subtracting 2, and I would get back to 3. So addition and subtraction are considered inverse operations. Likewise, multiplication and division are as well. If I started with 3 again, and I multiplied that by 2, that equals 6. If I wanted to get back to 3, I would just divide by 2, and that would get me back to 3. So multiplication and division, those are inverse operations. They have similar properties, just like addition and subtraction. Addition will undo subtraction, or vice versa. Multiplication will undo division, or vice versa. So in division, look up here at the top, I could have a positive divided by a positive. Those would be like signs that would yield a positive result. And I can have positive divided by negative, or the other way, negative divided by positive. Either way, you get a negative result. It yields a negative result because you have unlike signs there. And then negative divided by negative, that also yields a positive result because those are like signs. One way to understand division of signed numbers is, say you had this, 4 divided by negative 2. What you could do there is just do the absolute value part first. Just do 4 divided by 2, and you know that equals 2. Then add the negative back in and say, well, the opposite of 2. So your answer would be negative 2. And that would work even if it was negative 4 over 2. Just do your division first. 4 divided by 2, just of the numerical part. 4 divided by 2 would be 2, and then you put the negative back in and say the opposite of 4 divided by 2 would be negative 2. And then let's say you had a negative over a negative, negative 4 divided by negative 2. You could say 4 divided by 2 is 2, and then you have two negatives there, so you'd say the opposite of 2, which you've already understood to be positive 2, so you know the answer would just be positive 2 there. So in multiplication and division, when you multiply a pair of numbers together, if they have the same sign, whether they're both positive or both negative, you yield or get a positive result. If you have unlike signs, multiplying or in division, you get a negative result. Let's go ahead and do some practice problems now. Okay, in practice problem A, I want you to represent negative 3 times 2. Show me what that result is by using a number line. So what you do first is make a number line, and think about it. You can kind of visualize it first if you need to, and you know the answer would be a negative 6. So make your number line so it at least has negative 6 on it. Okay, and so what you're doing here is you can think of it a couple of different ways. You can do 3 times 2 and then figure out the opposite of that, or you can do negative 3 twice. That's how I'm going to do it, is just do negative 3 twice. So I'll start there at 0, negative 1, 2, 3, negative 1, 2, 3. And so you end up at negative 6. And so you can just write that as your answer. So I've written some more practice problems on the board. Why don't you pause the CD and see if you can figure out all of those, and then go ahead and turn the CD back on and see if you did them correctly. So in B, we have 5 times negative 2, so that would just be a negative 10 because we have unlike signs there. In C, that would be a negative 18 because there are unlike signs. In D, we have the opposite of 4 times negative 4, so the opposite of negative 16 is a positive 16. And then we also know that we have like signs there, so that should yield a positive result. E is a division problem. We have a positive 3 over a positive 3, so that's just equal to a positive 1. And we don't have to put the positive in front of the 1 because it's understood it's positive. F, negative 7 divided by a positive 1. We have unlike signs there, so that yields a negative result. And likewise in G, we have unlike signs, and just don't worry about the parentheses there. It's just you can think about them or just don't worry about them. You're just doing 12 divided by negative 4, and so that is equal to negative 3. Remember, on those you can just think of the absolute value part, or just the numerical part, 12 divided by 4, and then add the negative back in, say the opposite of that, so that'd be negative 3. And then the last one, we have like signs there, so the result would be a positive 7. Okay, well that's all for lesson 9.